at the basics of programming in C++ or just programming in general. The first off is just a brief understanding of what programming is and what programming isn't. So programming is being able to take an understandable, readable human language and have a program like Visual Studio compile it into machine language and have that come out as a program. Now, programming isn't being able to just sit down and suddenly snap your fingers and have a magical piece of software appear or anything like that. So today we're just going to be talking about the basics of installing Visual Studio, understanding what Visual Studio is, being able to make your first program, which is the classic Hello World program. So first off, this is Visual Studio. This is where most programming happens as a code editor like Visual Studio or various other ones like CodeBlocks and such. And what I mentioned earlier, Visual Studio essentially just takes a readable language and translates it to machine code so that your computer can understand what is being said to it. And that said, Visual Studio, Visual Studio has many different languages that it can translate, but our specific focus today is going to be on C++. First off, to be able to get Visual Studio, go to Google and look for the Visual Studio downloader. You go to Microsoft's website and grab a copy of it. Now, I already have Visual Studio installed, but I'll still run through the steps of installing every single bit of Visual Studio for you and how it all works. I and most people will typically use the Community Edition because it's free and it just comes jam-packed with absolutely everything. Now, depending on your operating system, you may end up using a different editor. I use Linux oftentimes, and I'll use Visual Studio Code, as you can see right here. But in Windows, I will always use Visual Studio Community Edition, or I'll use CodeBlocks, depending on the project I'm working on, because each have their talents and their faults. So go ahead and download that. I am going to give you a bit of a warning. The installer itself is small, but Visual Studio is ginormous. Sorry about that audio glitch for a second there, but anyway, Visual Studio itself is ginormous, but as you can see, I already have a copy of it. We're going to open up that installer, which is going to run its particular program, stuff like that. And I'm actually going to show you what to install because there's lots of different pieces and parts to Visual Studio, and the entire package combined is quite sizable. So when that installer loads, I'll guide you through the basics of running it. I should probably close that down. Okay. Okay, let's see if it loads on me here. Oh, there it is. Sorry, it happened off screen, didn't see there for a sec. So you'll get a window like this. You push continue, obviously. It'll download what we call the package list to Visual Studio from the Microsoft servers and stuff like that. And you don't need to understand a whole lot about how this process happens. You just need to know what to install and why. And this can take a minute because the internet can be slow and also it's getting quite a bit of data there. And I'm sorry if you hear any background noise. I try to keep it to a minimum, but it doesn't always go so well. So as you can see, I already have it installed, but you'll get a screen like this, and like down here, you'll see an install button for the Community Edition. So you push install, and it'll take you to a screen similar to this in a second. Now, I know a lot of you who've seen maybe videos like this or understand how these things go will notice that I'm not particularly giving like a history on programming or anything like that. It's because I really wanted to get into it. Now, depending on what kind of programs you want, you select different packages on this screen. Typically, if you're just going to do plain C++ and nothing else, you can just do desktop development with C++. You notice I have several different options selected around here. That you don't need to worry about at all. I know I'm going through here just to show you guys. This is for building Linux applications, which we'll talk about later, and we may not even use Visual Studio for. But for right now, just install desktop development with C++, and then push install. On the bottom right, it'll be somewhere down here. After all of that is done, we're going to open up Visual Studio, and you'll see a screen similar to this. We're going to push New, Project. And I always typically do Empty Project because all it does is it opens what we call the Windows console, or whatever other things you add into it later. But we're just going to be working with the Windows console for now, just as a starting point. So I'm going to do Hello World as the name of this particular program. And you can put spaces, but I just don't, because I don't really think the spaces that Windows will render look very pretty. So we put up a Hello World. And you'll see it starts to create a project, which means it's assembling all the files, getting everything together as it should. And mine always has a certain pause when it's creating a new project, but here we go. A very, very blank template. Now, I know a lot of you are probably asking me right now, Weirdbeard, why are you starting with C++, or why are we learning C++ if this is just a beginner's programming tutorial? Isn't C++ supposed to be like the big, bad, difficult one? It's actually a very interesting little dichotomy there. In my CS classes that I've taken in just over experience in studying such like that, I've found that if you start off with C++, you can learn any language from there. If you start from Python, it's not that you couldn't learn C++ or advanced, it's just much more difficult because Python is what we call a higher level language, meaning that a lot of the details that your computer needs are already done for you in different various ways. So it's like a language that doesn't need as much hand-holding as C++ does. Because like in Python, I can just print words to the screen. C++, I have to give it a command, tell it how the word prints, things like that. And I'll explain that here in a second. So now that we're in this window, we're going to right-click right here. And you'll see this menu appear right here. Go down to Add, New Item, and on this screen, we'll type main.cpp. And this is going to give us just a blank file as a blank template, as a blank everything. And the reason why I like to start blank is just because it's an easier canvas. It gives me more time to explain things. But overall, I think I just prefer programming with blank templates. So main.cpp is what we call the core or the beating heart of the program. Main.cpp makes everything run. Every single program has to have a main. And there's something about main that makes it very interesting in the sense of when you compile, or what we call compile, when you make your program runnable by the computer, it's always going to look at main first and then go back through the steps. Now, main, we always have what we call a function. Int main. And just type this as long as you see it. Return 0. Return. Whoops. Routine. Forgot an R there. Alright, so this is your typical C++ main file. it's going to look in here, and whatever you put in here is going to be executed. And that can be as simple or as complicated or as easy, backwards, whatever. That could be whatever you want it to be. But it's always going to come from main. Now, up in this area right here, this is outside of what we call the main function. We're going to do what we call including. So we type hashtag include open caret, which Visual Studio will automatically generate 2 carets like that, or 2 arrows. And in the middle of that, we're going to type IO stream, which stands for input output stream. Now, I'm not going to get into too much detail right now about what that is specifically or why that works. And then right below that, we're going to type using namespace STD, which stands for Standard Template Development. Now, in tutorials and when you're learning, using namespace STD is fine. In real full-on C++ programs, and I'm not going to get into too much details about this, you never, ever, ever add using namespace STD. And I'll explain why much later when we get to that point. But just know that this is for tutorials. And I guess I should explain this. So, in programming, we have what you call comments. // and what comments are essentially just lines of text that you can write that won't be read by your compiler, i.e. it won't be assumed that that's code. That's just assumed that that's just an English statement or whatever language statement that you're writing for somebody else to read that says maybe this code does this. But anyway, in our int main function, we have access to many different variety of things. With C++, we include things like IOStream because it gives us different functionality that's built into the C++ language. Since this is our typical hello world program, we write cout 2 carets parentheses hello world 2 carets endl semicolon. Now, what I just told it to do was to call the console output function to print hello world to the Windows console, and then print any other text after that on a new line. That's what endl stands for, end line. So that's console output, and then end line. Now, as I run it and I build it, we'll push that green arrow right there. You'll notice it takes a second to compile, which means it's reading the words that I wrote and translating it into a readable file for your computer. And then it'll open the program. And we'll just wait a minute for that to happen. But down here, in this window called the output window, you'll see a lot of data from Visual Studio. So like if I do something wrong, this output window will show it. Now you notice for a second you saw a black window with white text that said hello world appear and then disappear. Well, it's because of this right here, this return 0. Essentially what this program does is it gets called by the file that Visual Studio generates, the program that you run, and all it knows what to do is to just print hello world and then close. Return 0 means return successfully or close the program. So essentially I didn't tell the program to stay open, I just told it to return successfully. So print this message and then return. Now, to go on to explain what I was talking about earlier when it comes to this window right here, if I did something wrong, Visual Studio won't allow me to put things together. So like if I spoke the language wrong and the computer couldn't quite understand what I was saying to it, Visual Studio will crash, and it won't know what's going on, kind of thing. I'll show you. For example, if I delete that semicolon right there, and once again, I'll get around to explaining here in a second what those mean. You see a red line appear in return. It'll say expected a semicolon. If I try to run the program, it'll say there were build errors. Would you like to continue? If I say no, all of a sudden in this output window, it becomes the error list. It shows me there's a missing semicolon, and it's telling me that needs to happen before this return. Now, let's go on to explain a little bit more about what we're seeing here. So we know we're calling console out to print this hello world to the function, and we're calling a new line. Now, why, weirdly, do I need a semicolon? The semicolon is sort of like the delimiter. It's like the end of whatever you're typing. So it's the way that C++ can tell that you've ended the line that you've typed. So every single time that I create a new line or I create a new statement, I have to have that semicolon to tell C++, this is a line, go to the next one. This is a line, go to the next one. This is a line, go to the next one. If you don't have that, it's not going to understand what's going on. Now, this int main that my cout is inside of is what we call a function. A function is essentially a box of code that I can hold in one. So like if I wanted to have, for example, a print name function, I would create a box called print name. And in here, I could just put a simple cout. My name is Weird. So cout, console output, my name is Weirdbeard, end line. That void print name is now a separate box from int main. So that line of code is in a separate space, is in a separate room, is in a separate box than my hello world. Now, I'll explain what void means in a minute, but I'm just going to run the program to explain to you what that means, what having them in a different box does, and why that's important. So if I run this program right now, you'll see that it'll compile because I put the semicolon back, so there's no more errors. And the only thing that appeared was hello world. The reason why this is because, like I mentioned earlier, this print name is an entirely different room. It's an entirely different box. So main has no understanding that that print name function exists. The only thing that main knows is that it exists, and it's telling me to print, and I'm telling it to print hello world because that cout hello world statement exists. However, what I can do is tell main to open that box. So I call print name with the two parentheses, semicolon, and I forgot to put the name part. There we go. Now you'll see that there's no red lines, and that it has void print name, the name of my function right there. What I've essentially done is I've directed C++ to run the print name box, to open that box and say, hey, there's a line of code in here. I'm going to run it. So we understand now that cout is console out, meaning I want to print to the console, or screen in this case, shouldn't be capitalized, old habits. And a function is simply just a box of code that can be called separately. Now, I know I'm going a bit quick here because I have a very limited amount of time. I'm only going to be running this for about 30 minutes and we have about 10 minutes left. There's one other simple thing that I want to touch on in this subject, or in this particular tutorial. Variables. So, every programming language has something called a variable. That variable can be an int, a string, a char, a bool, a double, or a float. Now, I'm going to explain what each and every single one of those are very, very simply. A char is also known as a character. A char in C++ can hold up to 3 letters. Any more than that, and it's not a char anymore. It becomes a different data type. And I'll explain what that means in a bit as well. But a char is just simply me telling C++ that this is a character. Now you notice I typed char h. H is a box of box for that character to be hosted in. So imagine like I just took a cardboard box and wrote H, and then I told the person who's speaking C++, so the person who's speaking Chinese and I'm speaking English, this is a box of letters. So essentially in this box there's letters. Now if I do char h, I put the equal sign. I'm assigning to h whatever letter I want to assign. So this is char h equals ABC. What C++ is saying here is h is a box of characters, and those characters are A, B, C. If I go beyond that 3-character limit, you'll see something interesting. Or, not 3 characters, 4 characters, let's see. If I go above the character limit, yes, so 4 characters, okay. Yeah. So, a char can hold 4 characters. Anyway, if I go above that limit to say 5 characters, you'll notice there's an error. Because now we've created a totally different data type. But anyway, like I showed you before with that cout function, I can actually print that char, those characters, to the screen. So I do cout h and L. Now if I run this, you notice that for a brief moment you can see hello world and you could see D. And I'm going to explain why only D appeared in a bit. Well, actually, yeah, probably next lesson. Anyway, so that's what chars do. So chars stand for characters. We have int. Now int is simply just the numerical values, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's nothing special about int other than that. So I can go and I could print out that number instead. So if I do and hit play, of course, there's a small little bit there, but that's beside the point. It's because I have too many numbers in this particular piece. So an int can be up to a certain range. Anything above that range, and you'll end up having problems. But that's why there's different data types to hold different types of numbers and such else. But for example, I type 1, I print, 1 appears on the screen. I can make that 500. Now the reason why we have different data types is because we need to do different operations with them. Char specifically means like a letter, so it's like a glyph, for an example. But at the same time, I can also put numbers in here. So if I put, and I hit play, or I went past, the 4 character limit. Whoops. And I hit play. Forgot something. Sorry, I'm kind of rushing right now. Alright, so one more thing I'm just going to explain. Never, ever, ever use this unless you're doing a tutorial or you're explaining something. That's just a way of pausing the console, but it also can be really dangerous. I just do it just because it's a quick thing I could do for the tutorial. But anyway, so I hit play right now. And you notice that in the char, 4 appears. The number 500 appears. So both of these things are printing. Why would I want an int versus a character? Because an integer is like a mathematical number. For example, if I did cout number plus plus, or if I did, let's do which means number plus one, and plus plus is plus 1. And I ran that, you'll notice now we don't have the number 500, we have the number 501. I cannot, however, do that with a char. Because, well, I can add to a char, but it's a different whole operation altogether. And then I think for right now, so yeah, I can add to a char, but that's a totally different number, or that's a whole different operation. Other than that, we have bool, which means, dang it, I forgot. Which it means true or false. So in machine language, everything is represented by a 0 or a 1. True or false. A boolean is simply just that, a true or a false. So for example, if I were to say that's false, and I said if what is equals true, now you notice that I put carrots. You know this is the whole thing. I'm not going to go into too much detail about what this is specifically just yet, but to give you the basics, this is essentially just me saying, alright computer, if this boolean, if this particular variable is true, complete these actions or do this, instead of, say, the alternative, else. Right there, the bool is false, because I've set what is to false. If I change that to true, then all of a sudden you see the numbers reappear on the screen. 501 because I'm adding, and 1 because that char h only holds the character 1 in this case. Alright, I'm going to leave it off here for today, but thank you for joining me. Have a good evening.